Here is a question number 318 from Irodov from fluid mechanics or hydrodynamics, and in the question it is given that a wide vessel with a small hole in the bottom is filled with water and kerosene. Neglecting the viscosity, find the velocity of the water flow if the thickness of the water layer is equal to h1 and that of the kerosene layer is equal to h2. Now this is the corresponding diagram of the given question. Now there are two layers of water and kerosene. As we know, the density of kerosene is lower than that of water, so kerosene layer will be on the water layer, and the thickness of kerosene layer is h2 and thickness of water layer is h1, and there is a small hole in which the velocity water emerges from it. Let the velocity of the water is v from the hole. So let us assume 2 points, one point is 1 and another point is 2. So we will apply the Bernoulli equation at the point 1 and 2. Applying Bernoulli equation, Bernoulli's equation at point 1 and 2 will get, now P1 is the pressure at this point, P1 plus half rho 1 V1 square plus rho 1 GH1 will be equal to P naught, because the point number 1 is, let this point is 1 and this point is 2. Now point 2 is free to atmosphere, so its pressure at point 2 will be equal to atmospheric pressure, that is equal to P0. So Bernoulli equation for point 2 will be P naught plus half rho 1 and its velocity is v plus rho g h2. Now h2 is rho g h2 and h2 is equal to 0 because it is the ground or datum level. So we can write this equation as P1 plus half rho 1. Now V1 is again equal to 0 or approximately 0 because here there is no velocity between the inside the container of the liquid, or in comparison of the velocity v, the V1 is very less, so we can equate this term is also equal to 0. So this total term will be equal to 0 plus rho 1 g h1 equal to P naught plus half rho v square. So our equation number 1 will become P1 plus rho 1 g h1 is equal to P naught plus half rho 1 v square. Now we'll consider this point. Let this is point 3 and this is point 1. Now we'll consider the pressure equation between point 3 and 1. From this, as the height difference between point 1 and 3 is h2, so and 3 is the upper point, so we can write the pressure at point 1 will be P1 equal to P naught. P naught is the pressure at point 3, P naught plus rho 2 because density of kerosene layer is rho 2 G H2. Now this was our equation number 1 and this is our equation number 2. Now we'll substitute the value of P1 from equation number 2 to equation number 1. Then our ultimate equation will become P naught plus rho 1 G H1 plus rho 2 G H2 will be equal to P naught plus half rho 1 V square. Now we can cancel this P0 term from both sides. After cancelling, our value of V square will be equal to rho 1 G H1 plus rho 2 G H2 divided by and 2 times this divided by rho 1. So our velocity, square of velocity, will become, if we take common 2g, then after taking common 2g, our term will be rho 1 divided by rho 1, that means 1 into h1 plus rho 2 divided by rho 1 into h2. So this is the value for v square. Now we'll find the value of v. If we want to find the value of velocity of a flask or velocity of the water from the hole, that will be equal to v equal to under root 2g h1 plus rho 2 divided by rho 1 times h2. So that is the velocity of a flask or velocity of the water flowing through the hole.